Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Hello, everyone. Dear researchers, welcome to our third international conference on water problems in Mediterranean countries, as well as our sixth international conference on natural resources and sustainable environmental management. This is Room 2, Session 2. I will be your moderator. We have our presenters ready, and our first presenter is Dr. Necati Ağralioğlu. Dr. Necati Ağralioğlu, if you are ready, you have 15 minutes of time allocation. If you are ready, you can start.
Okay, I am ready. Okay, thank you. Good afternoon, everybody. My name is Necati Ağralioğlu. Our paper title is Determination of Evaporation in Cyprus Island. We are, as me and Burak Emre and Tulin Şençopur, Sila Canbulat and Mevlüt Bozkurt, we prepared this paper. This is our contents of paper: introduction, material and method, population, temperature, precipitation, evaporation, conclusion, references, and so on. There are some information about our Cyprus Island, and especially for northern Cyprus Island, Cyprus. And so maybe you can read from this one. And there are some literature related to our topic. For instance, one of them is Nikos, as a study was conducted for southern Cyprus for water resources. And there are some others estimated to have been made since 1995 to determine the water needs of northern Cyprus and some other things and so on. Now we are interested with evaporation in Cyprus. Evaporation is affected for many factors, as for instance, temperature, precipitation, wind, relative humidity, surface area of dams, and natural lakes, and some other things, especially even land use. And so for this purpose, we were interested with determining the water resources in Cyprus, especially for future. And so we were interested with population, temperature, and precipitation, and especially for determining the evaporation. Materials and methods, you see here some statements related to these topics. And so in northern Cyprus, there are 33 meteorological stations, and the southern Cyprus, there are 66 meteorological stations, and we will consider both of stations. And now we use some methods to estimate the evapotranspiration. One of them is Branel-Crittell method. This is the formulas, and Hergewist method, and these formulas, Hammond method, and finally Thorne-Waite method, and so on. We start to estimate the population chain in Cyprus. There are three different areas. One of them during the British era, and we see the data of population of Cyprus during British area. And this is the graph of these figures. Population of the southern Cyprus between 1950 to 2021. And you see the variables of this population change. And population in Turkish Republic of Northern Cyprus, we have some data, we plot the figure, and then this is the world population by years. We want to interested with world population as a growth ratio per year, and we use this growth ratio per year for world population in Cyprus. And so, for instance, while the world annual population growth rates 1.85 in 1975, this rate was 1.8, and so you can see some data. We use this data, we want to estimate the future of population for southern and northern Cyprus. This is southern Cyprus estimations. This is the northern Cyprus population estimation. And so, according to these calculations, the population in southern Cyprus was calculated as 9,087 and 576 for 2031, and so on. And so for the calculation for North Cyprus was found like this, 417,100 for 2031 and 2041 as this one. Also, we are interested with temperature change. You see the months, total months, and you see December, January, February, and March, April, May, and so on. There are some large years between this one and between this one and between this one. We want to check, is there any trend in this temperature? You see in Mediterranean Sea, and especially in Cyprus, we have some trend in temperature as increasing the temperature. And you see the temperature figure, as you see the period, this one is a blue one, the red one is this between this one and so this one, and finally this one, as you see. This is almost the same, but you see the temperature increase by years, by periods. Temperature for northern Cyprus, you see these average values and so on. Precipitation also, we consider in this one, precipitation Cyprus Island, we have the same data, and we plot the figure like this. You see temperature in this one, and this one, and this. The blue one is the last period, and you see the blue one. There is almost no increase in our precipitation in Cyprus Island. And precipitation for northern Cyprus, you see the northern Cyprus here. We can obtain some values. And also, there is a little bit increase in our precipitation, average precipitation per year in northern Cyprus. And evaporation is our main subject in this project. You see some data calculated by us as Human method for KKTG and northern Cyprus. And so another one, third weight method results, you see, we can calculate all of them for different years, for different months, our evaporation values. And also another method, this one, Harvest's method results for totally 33 stations values used for these calculations. And Blaney-Criddle is another one, calculated also for 33 stations for different years. And we compare all the methods for each month, and you see Hammond and Blaney-Criddle and some other things. We plot these figures in a graph. You see this, the horizontal line is months, the vertical lines is the evapotranspiration. You see the different solution. The blue one is Hammond. This one, Harvekis, is the most different values, and Blaney-Criddle is the yellow one. And so also we can compare the evaporation results with Lefkosia meteorological station results. You see Harman, Thornweight, Harvest, Blaney-Criddle. We compare both of them, as you see, for Lefkosia. And also we compare, this is very interesting results, we compare Hammond method for 33 stations, and Hammond method for only Lefkosia meteorological stations. And so we can obtain this one for Hammond results. The yellow one is Hammond method result for 33 stations. This is Hammond method for only Lefkosia meteorological station. And also the other method, you see the results. And another one, you can see the comparison. And so actually, you can see the Blaney-Criddle is the same for each month. You see the similar values we obtain. You see this figure, 33 meteorological station in northern Cyprus using Blaney-Criddle, the blue one, and for only Lefkosia meteorological station, this is the yellow one or brown line. And so you see there is a little bit difference. So this means for practical purposes, we can use only the Lefkosia meteorological station data instead of 33 meteorological stations data. And we use some methods, as you see, for instance, for optimization, calculation, our average evaporation. And so you see the figure. We use this inverse distance weighting for 33 meteorological stations. And you can see our meteorological station in northern Cyprus, and they use this by using ENÇESU method. And conclusion, maybe you can see in this study, the future evaporation of the northern Cyprus and southern Cyprus are estimated as a basis for determining the water and need of the island of Cyprus. For this purpose, our purpose is the evaporation. The future population of the northern Cyprus and southern Cyprus were determined. We want to estimate the future need for Cyprus water resources. On the other hand, the future situation of the precipitation in Cyprus was evaluated for northern Cyprus and southern Cyprus. Monthly average temperature values, which are the most important parameters affecting evaporation, were examined for Cyprus in this study. And evaporation in northern Cyprus were estimated with 4 different methods, and the results of these 4 methods were compared with each other. Evaporation of 33 meteorological stations in northern Cyprus were evaluated and compared with the Nicosia meteorological values. And so there was a maximum of 5% difference between the evaporation values of only Nicosia meteorological study and monthly evaporation values of 33 stations. In this comparison, the least difference was seen in the Hammond method, especially in the Dane-Criddle method. Maybe we can add this another term. Monthly evaporation of that northern Cyprus Nicosia meteorological station was compared with the southern Cyprus Nicosia meteorological station, and maybe sometimes we can use both of them for each other. Thank you for your listening to me. Okay. Is there any question?
Thank you, Professor Necati Aralioğlu, for your valuable insights for Cyprus. Thank you for also attending the conference. Next is Dr. Kübra Doğan will be with us and presenting his findings.
Today I will talk about our study on integrating sustainability with traceability for bisphenol A removal from tap water. First of all, I will talk about the aim and scope of this study. Later, I will give information about the material and method we used in this study. Finally, I will present the result of these studies to you. Importance of the study. Bisphenol A is used as an intermediate in the production of polycarbonates, plastics, and epoxy resin. The current study aims to combine traceability result with a sustainability assessment. Aim and scope of the study. The goal of this study to evaluate the environmental impacts of laboratory scale water decontaminations studies and to choose the best method from among those used. The research focuses on the energy and chemical management of water treatment processes. Using a laboratory-based photochemical oxidation method, conditions that completely remove BPA from water with UVC, activated sodium persulfate, sodium percarbonate, and hydrogen peroxide have been used to determine the effects on the environment. Material and methods. Removal of BPA from tap water is performed by using UVC activated sodium persulfate, sodium percarbonate, and hydrogen peroxide as the photochemical oxidation process. Peroxide concentration with different levels of energy input are used. Gabi software and equipment database with CML 2001 impact assessment method. The research has been carried out following the ISO 1440 and /40044. The functional unit is 1 cubic meters treated tap water. SPS, SPC, and HP used in obtained from China after 18,625 km sea and 19 km height-way transportation. Turkey's electricity generation consists of natural gas 19%, lignite 15%, hard coal 22%, hydraulic 29%, and others. The CML environmental impact categories investigated are as follows: global warming potential, abiotic depletion potential, acidification potential, eutrophication potential, freshwater aquatic ecotoxicity, human toxicity potential, ozone depletion potential, photochemical ozone creation potential. BPA removal from tap water. And the first table on the slide shows the environmental working conditions. As seen in the second table, 3 different experimental studies were carried out by Öztürk et al. For UVC activated SPS. In these 3 different runs, 100% BPA removal efficiency is obtained. The amount of electricity consumption varies depending on the amount of chemical used in the run. This page, the table above shows 3 different experimental studies were carried out by Öztürk et al. For UVC activated SPC. The table below shows 3 different experimental studies were carried out by Öztürk et al. For UVC activated HP. All runs 100% BPA removal efficiency is obtained. The amount of electricity consumption varies depending on the amount of chemical used in the run. System boundary for life cycle assessment in the laboratory scale treatment using sodium persulfate and UVC are indicated in the figure. The production and transportation of chemical used during laboratory studies and the electricity consumption used in the study are within the boundary of the system. The process from the purchase of the sodium persulfate raw material to the removal of BPA from the tap water has been evaluated within the scope of the system. Production of the tap water containing BPA and tap water treated from BPA are excluded from the system boundary. This system boundary for life cycle assessment in the laboratory scale treatment using sodium percarbonate and UVC are indicated in the figure. The production and transportation of chemical used during laboratory studies and the electricity consumption used in the study are within the boundary of the system. The process from the purchase of the sodium percarbonate raw material to the removal of BPA from the tap water has been evaluated within the scope of the system. Production of tap water containing BPA and tap water treated from BPA are excluded from the system boundary. And this page shows system boundary for life cycle assessment in the laboratory scale treatment using hydrogen peroxide and UVC are indicated in the figure. The production of transportation of chemical used during laboratory studies and the electricity consumption used in the study are within the boundary of system. The process from the purchase of the sodium hydrogen peroxide raw material to the removal of BPA from the tap water has been evaluated within the scope of the system. Production of tap water containing BPA and tap water treated from BPA are excluded from the system boundary. This table shows the environmental impact per 1 cubic meters of treated tap water for 9 different studies. As can be seen in the figure, the environmental impact values of the run one study were accepted as 100%. And then the percent of other experiments depending on this ratio were determined. When the percent change in the graph are examined, the lowest percent in the all environmental impact categories is seen in the round 9 study. The contribution of different factors to environmental effects is shown in the figure. In all environmental impact categories, it is seen that the biggest impact is from electricity. The contribution of chemical production to the environmental impact category is second only to electricity. The factor with the lowest contribution seems to be transportation. Conclusions. All the results show that energy input is the most important contributor to all the environmental impact categories. After that, chemical production comes. The round 9 study has the lowest environmental impact in all categories. The round 9 study with 6.8 milligram slash leather, sodium persulfate and 0.154 kilowatt-hour slash cubic meter electricity. Because the least electricity and chemical consumption among BPA removal studies from water was realized in the round 9. Transportation does not have a significant effect on impact categories. On this slide, you can see all the references used in the study. Thank you for listening.
Thank you very much, Dr. Küplandoğan, for your valuable insights. Now, the next speaker is Dr. Awala Saleh Mubarak.
Good afternoon. Welcome to the third International Conference of Water Problems in the Mediterranean Countries 2023. My name is Awal Saleh Mubarak, and today I will be making a presentation on the prediction of chemical oxygen demand in Nicosia wastewater treatment plant using hybrid metro-environmental data. So, in the outline as usual, we have the introduction, artificial intelligence, data sets and data pre-processing, model training, results and discussion, and also the conclusion. As we all know that the wastewater treatment plant is a complex system that is affected by many factors such as the political, environmental, industrial factors, and also the climate. So it is very important to take a look into the inflow and the outflow parameters of this wastewater treatment plant. The outflow parameters are very important because we need to discharge treated effluent out of the wastewater treatment plant. This is very important when it comes to human consumption and agriculture. So in this, we'll try to see how we will make the prediction of the effluent parameter of this wastewater treatment plant based on machine learning models, unlike the traditional methods. The main aim is to predict the chemical oxygen demand in the new Nicosia wastewater treatment plant by selecting the data and processing it, and also by selecting the machine learning models for the prediction of the COD, and also improving the performance by applying an ensemble technique. Artificial intelligence, as we all know, is synthetic intelligence, so we can say that intelligence based on algorithms and statistics that mimics human intelligence actually. These models or algorithms are used for making decisions by giving them variables to learn from them and then make a certain decision. So the new Nicosia wastewater treatment plant is a bicommunal wastewater treatment plant situated in Cyprus, and the project of this wastewater treatment plant from the beginning to completion will take up to 2025, and it is one of the main source of clean water and also the water for agricultural purposes in the island of Cyprus. So the new Nicosia wastewater treatment plant's data contains many variables. For the input, we are going to use the conductivity, the total nitrogen, total phosphorus, the pH, and so on, and also one effluent parameter, which is the COD. For the NASA data sets that we are going to use, we are going to use the relative humidity, the skin temperature, and the maximum temperature of daily meteorological data. And also, we'll use the 75% of the data for training, and then the validation will use the 25%. And all this data will be normalized into zeros within the range of 0 and 1. So in this study, we are going to use three different models, which one is the traditional linear regression, and also we're going to use the least squares for vector regression, and also the Mr. Winner. These models they work in very different ways. They have all different algorithms and decision making processes, which are all unique. That is why we try to employ them. So for the ensemble, we are going to use a weighted average ensemble technique in order to improve the performance of the model. So in the methodology, we are going to one pre-process the data after making the correlation and everything. We pre-process the data and we normalize the data into zero sum into between the range of 0 and 1. And also we'll try to train the model or the standalone model using the wastewater treatment plant data, which is C1, and then we'll use the meteorological data, which is C2, and then we try to train the model using the hybrid data C1 and C2. That is the combination of the two to predict the COD. So after training the model, we'll have different results based on the selection performance evaluation criteria. So for the first data, which is the wastewater treatment plant data, it turns out that the MLR performed very well. While for the meteorological data, it turns out that Mr. Winner performed very well, and for the hybrid data, that Mr. Winner outperformed all the models. After looking into this result, we find out that the combination of the hybrid data with Mr. Winner model tends to improve the performance of the model. This shows that the Mr. Winner performed very well, and it is very important to use the hybrid data. And also to further improve the performance of the model and have better fit, we try to use the weighted average ensemble, and with this we get 0.97 DC or fit, which is almost 97%. This shows that the model has the ability or capability of up to 97% to chances to predict the right values for the chemical oxygen demand. This is all about the result from the standalone models, and also in the conclusion we'll see that based on the complexity of the system, we were able to deploy machine learning models in order to predict the chemical oxygen demand, and we are also able to improve the performance of the prediction of the chemical oxygen demand using the hybrid data, which is the wastewater treatment plant data and the meteorological data. And also we showed that ensemble technique can also improve the performance of the model in order to make the right prediction. Thank you all for listening. This is the end of my presentation.
Thank you very much, Dr. Awale Saleh Mubarak. That was our last presentation in session 2, and we will continue in session 3. Thank you very much for those who attended.
Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarın yakın. Hepimizi ileriye götür.